I want to thank the Key Biscayne Community Foundation for making this event possible. We are so, so grateful for their support, and we really, really, really couldn't do what we do without them. Amen. We have quite a lot to cover today, so I'm not going to take much of your time. For those of you that don't know, my name is Ramya Sundaram. I'm the Director of Environmental Science for the Key Biscayne Community Foundation. And we try to do these talks once a month, usually the last Thursday of the month. Today, we have with us Bianca Sproul. She is working at NOAA currently. She's going to be our moderator with our panelists. And we have Gus Alaka from NOAA and Adriana González Fernández from Miami Waterkeeper. With that, I'm going to give it to Bianca.
Thank you. So what we're going to talk about today is Miami Waterkeeper. So how the presentation is going to go is AOML is going to go first and talk a little bit about the work that they're doing in hurricane research, how they collect that data, and we're going to go from top to down to local, and then go from there and talk with Miami Waterkeeper and really get to know more about how that impacts our water quality.
Hi everyone. I'll introduce myself while we get the technical issues sorted out. So I am Gus Alaka. I am the new director of the Hurricane Research Division, which is at the Atlantic Oceanographic and Meteorological Laboratory, or AOML, right down the street across the bridge on Virginia Key. So I'm very excited to be here today. Thank you very much to the Community Center for inviting me. This is an excellent opportunity. And actually, believe it or not, this is my, let me do the math here, 13th day on the job. So, but I have been at AOML for 10 years, so I have quite a lot of experience, and as I'll talk about today, some of the activities include flying on the aircraft, in the Hurricane Hunter aircraft, to collect this critical data. I've done plenty of that, over 50 passes through the eye, as we call it, and so plenty of experience there. I do want to touch quickly on the other parts of AOML, because we're a collection of diverse scientists. So I am at the Hurricane Research Division, which is shown in the lower left there. Over here, so a nice picture in the eye of a hurricane. There's also the Physical Oceanography Division, which focuses on a number of different ocean problems, not just related to hurricanes. And also the Ocean Chemistry and Ecosystems Division. And so together, I think we really take a really diverse point of view on what's happening in the Atlantic region and across the globe, but really focused on what's happening in the Atlantic. So a little bit more about what I do specifically. So I am a part of Team NOAA. That's the National Oceanic and Atmospheric Administration. That's sort of our parent, right? Arm of NOAA that you're probably familiar with, the National Weather Service. They get all the headlines. But there's another arm that's really important as well, the Office of Oceanic and Atmospheric Research, or OAR. And so that is where AOML actually resides under, that OAR, you know, government bureaucracy with all the hierarchy and all that. But we reside under that OAR side. And one of the most important things that we do is the critical research that feeds into how we improve hurricane forecasts at the Hurricane Research Division in particular. So I wanted to start here, just a little bit of background in terms of what the Hurricane Research Division's mission is. What are we trying to do? So I put it up here, and I'll just read it out loud, but we want to advance the understanding and prediction of tropical cyclone track, intensity, and structure change, sort of like what the storm looks like. Helene here is really wide, right? That's an idea of like how we would look at the structure. And their impacts. And we use observations, we use numerical models, computer models, and we also use theory. And so we have these different research themes that we organize ourselves under. So we look at observations, we do data assimilation. That's a fancy word for how do we use the observations in our modeling to make the forecast better. And then we also do the model development as well. That's actually where a lot of my background lies in doing the model development before I took on my new role. And as I mentioned earlier, we tie this back into what are the impacts, right? We want to provide more guidance on what are people going to feel on the ground. So one of the things we focus on the most are what are the winds near the surface really going to look like as the storms evolve, and how can we communicate how those winds and how the storm structure is going to change hazards. And we don't make the forecasts ourselves, but we provide critical guidance that make the forecast better. So we work really, really closely with our partners over at the National Hurricane Center. They kind of get all the glory, and they deserve it because they're the ones making the official forecasts. But we really play a key part in figuring out how they can make those forecasts better and giving them the guidance and tools to make sure that the forecasts are as accurate as possible. And Although I don't have it up here, the forecasts from the Hurricane Center have gotten so much better over the last 15 years especially. The errors have gone down by about 50%. So that's a remarkable improvement over that time. And that's not all because of us at HRD, but we play a pretty critical role, and we're always communicating with them how to make their forecasts better. I put this image over here of Hurricane Beryl, which was Category 5 earlier this year. It was actually the earliest Category 5 on record in the Atlantic Basin. Luckily stayed away from Florida, but it actually did eventually make its way into the Gulf of Mexico and ended up making landfall near Houston as a Category 1 hurricane. So my crew, my team flew several missions, I think 16 in total, into Hurricane Beryl, collecting critical data in order to make sure that the forecasts were as accurate as possible. There was some uncertainty earlier on saying, oh, was the storm maybe going to go further north and maybe hit a different part of the U.S., including Florida. So the data that we collected was critical in terms of reducing that uncertainty and making sure that the forecasts were as confident and accurate as possible. So I want to take a moment here to talk about what do we think the season was going to look like. And we're already past sort of the midway point of the year. The peak of hurricane season is on September 10th. But so far, this actually does not include our latest storm, Helene, so this does need to be updated. But the forecast called for 90% above normal, and only 10% near normal, and 0% below normal. So our forecasters were very confident in the fact that this was at least going to be an average year, but probably a very active year. And I'll touch on, how that's played out a little bit, but we still have a ways to go. So there's been a lot of news reports, I would say, and they're not wrong about, there was a quiet period and what does that mean for the overall activity. We still have a ways to go, and I'll add that as we get into later parts of the year, the activity does tend to shift west toward the Gulf of Mexico, and so that obviously brings it closer to home, right? And so with storms forming so close, there can be less lead time. And so we really want to make sure we're predicting these storms as accurately as possible to reduce that uncertainty. So, so far this year, I'll just do the math on my own here. We've had 8 storms, counting Helene, 5 hurricanes, and soon to be 2 major hurricanes. Helene is well on its way to becoming a major hurricane. What does it look like so far? And again, I'll add this I did not get a chance to update it because Helene just formed a couple of days ago, so this is not counting Helene in these statistics, but we had a really active start. This chart here is sort of showing, on the y-axis here is sort of the left axis, how much activity we have, a measure of that. It's not necessarily storm count, it more takes into account how strong those storms are, but the yellow line is what we've had this year so far, and sort of this blue curve is what is expected in an average year, the climatology as we call it. So Beryl set records earlier on. It jumped up this activity to levels that we had never seen in early July, and then things sort of leveled out. We had some other hurricanes mixed in there, but nothing that really ramped things up, and you can see by the time I put this plot together, this yellow line met the blue line, meaning we were at an average year, right? But I'll caution, but even though we like to look at these metrics from a forecaster perspective, it only takes one, right? Hurricane Andrew came in a year, 1992. There were only 5 storms total that entire year. So keep that in mind. It only takes one, but this is how we sort of track whether or not it's an active year or not. And so as we go forward, we are expecting, as I mentioned, a late season ramp up. There's a couple of factors. What this is showing are sea surface temperature anomalies. So sort of like where it's yellow and orange and red, it's warmer than usual. Where it's blue, it's colder than usual. And so there's a couple of things that stand out. First of all, it is still very warm in the Atlantic Ocean where these temperatures are well above average, and these oceans provide the fuel. This is the energy that these hurricanes feed off of. So the warmer the oceans are, the more fuel there is for these hurricanes to grow. And so that's something we're being very mindful of. Also, La Nina is developing in the Pacific, and that's illustrated here by these blues. La Nina means that the equatorial Pacific is cooler than normal. And you might say, why does that matter? Well, there's all sorts of ripple effects, we'll call it, that the ocean temperatures in this section of the world have. Especially these ripple effects make their way over into the Atlantic. And one of the things that La Nina does is makes the upper level winds nicer for her if you're a hurricane. Or for us, not as nice, because we don't want those hurricanes to be able to stand up and grow. And as I mentioned earlier, activity tends to focus over on the western part of the basin in the Caribbean and the Gulf of Mexico. So we are expecting a late season ramp up, and I think we're already starting to see that right now with Helene's activity. So more specifically about the role that me and my team play in this. So we sit at AOML, and that is a laboratory, but I like to tell people our laboratory is actually up in the sky. We fly on the NOAA aircraft The depth perception here is a little weird. This aircraft is actually larger in the background. This is a NOAA P3. We have 2 of those aircraft. And in the front is a smaller jet. And these aircraft are named, I always giggle at this a little bit, but Miss Piggy and Kermit are our 2 P3s, and Gonzo is our high altitude jet. These aircraft are so important for collecting data that gets in front of the forecasters, gets into the computer models, and we're always working with our partners at the Hurricane Center and the Air Force to make sure that we are optimizing the way that we're doing our work in collecting this data. And I love this image on the right. Here's an image, I believe this is Dorian, Hurricane Dorian from 5 years ago, 2019. You can see all of these aircraft. These are commercial aircraft, and they're staying away from this storm. That's very good. And here's one in the eye. What are they doing? Well, that's our crew. We went right into the eye of the storm. So these are our laboratories, and they are equipped with a number of advanced instruments that are both well-tested and what we call operational, meaning everyone says, yes, that's amazing. And we're also doing stuff on the emerging technology side. What's the next thing down the pipeline that can make the forecast even better? So we try to straddle that line as best we can, and we do all of that on our aircraft. So I have a couple of videos that I'll play here. The first one is showing you what it looks like inside of our laboratory. And you can hear that hum. Believe it or not, that hum is there the entire time. You know, it's about 100 decibels or so. And these missions typically are about 8 hours long, so they are not quick missions. And there are a number of different stations here where people are doing different important work, including making sure that the instruments are getting out of the aircraft. All the instruments that we're measuring with are doing things optimally. We'll let this sort of play out here. And the sound actually doesn't even do it justice for how loud it can actually be on those aircraft. So a lot of people have noise-canceling headphones and things like that to sort of make it a little bit less noisy for them. But this laboratory in the air, again, as I mentioned, is super critical to the work that we do. And it's not just the NOAA, the scientists that are on board. We have a number of important partners. The crew on board does an amazing job. The pilots, the flight directors. The flight director is actually sitting, I went too far, but on the left there was the flight director, and on the right was our nav. The crew is really doing a great job of figuring out where can we go, and I like to say it's a negotiation. I'm the crazy scientist saying, we want to collect data in this part because that's where the maximum wind is, and that's the data we need, and sometimes they say, okay, we can do that, and other times they say, Gus, that's a little crazy and unsafe. We're not going to go there. We're going to get as close as we can while keeping everybody on board as safe as possible. So now what does it look like outside of the aircraft? Again, there's that hum. This is looking out the window, so these are prop airplane. You can see there's the propeller spinning around out there. Going through the eye wall, you typically see, heavy rainfall streaking across the window. And all of a sudden, that starts to diminish a little bit, and you'll see in a minute open up into this almost paradise of clouds and calm in the middle of the storm. So here it just crossed over into the eye. And I think the video will pan around here in just a minute, and you'll get an idea for what this looks like. There's the open sky above, and you can see the curvature of the eye as well with those clouds sort of circling around the center. I wanted to touch on, as my last slide here, on hurricane modeling of the present and future. So one of the things we do is we do use these observations to make our models better. These are computer models. And so at the present, we have this new system that I helped develop along with a number of other people across NOAA. And this is called the Hurricane Analysis and Forecast System. And this is sort of a colorful plot showing a forecast for Hurricane Lee last year, which luckily did not make landfall in the United States. But you can see that structure where you have an eye, open eye in the middle. You can see it organizing here, starting to spin, and you get all of this really strong thunderstorm activity circling around it. And where are we going? Well, we want to be able to build an integrated system where everything is sort of done in one global model that takes care of weather all across the world. Now, NOAA already has that, but we're hoping to add these little boxes here. What do these do? These are like special magnifying glasses that help us get high-definition forecasts over storms that we want those high-resolution forecasts for. So essentially, when you're forecasting a hurricane, getting the resolution as fine as possible, and what I mean by that is essentially you need to be able to resolve these clouds. You need to be able to get down to the scale of where the clouds are, where the sharp moisture gradients are, and how they're actually spinning up. So these windows, so to speak, these magnifying glasses can follow storms all over the world, and we're working on that right now. So with that, I will turn it over to Adriana. Where's the
Hello, everyone. I'm so happy to be here today with you all. My name is Adriana González Fernández. I'm the new Science and Research Director at Miami Waterkeeper. If you're not familiar with our organization, it's a local nonprofit, and we're dedicated in protecting Miami and surrounding areas' waters. So today I'm going to talk a little bit about our water quality data. You might have seen us, our techs out there taking samples here in Key Biscayne and other areas, and taking all that data about our water quality. So today I'm going to focus on how some of the storms that we can have an impact on that bacteria levels that we use to measure the water quality. So as you probably might be aware, already know, swimming in sewage polluted waters can make people sick, right? There are so many different microbes that can make people sick. So we have different types of parasites, bacteria, viruses. You can see there's like a funny drawing. You know, we have norovirus, adenovirus, all of these different microbes that can make people sick. So the thing is, we can't measure all of those microbes, not only because it's logistically challenging, but it's also really expensive, and it can be dangerous to work in the lab with all of those different microbes. So for that reason, when we do water quality monitoring, we don't focus on measuring all of those microbes that are there. We use fecal indicator bacteria. And that means that we use bacteria that are normally present in the gut of humans and other animals at very high concentrations, which means it's really easy to measure them in the environmental waters where we swim, where we recreate, where we're with our children, right, on the beach playing. So we measure that bacteria, especially in beach water and when we're swimming in the ocean. It's called enterococci. And that bacteria, enterococci, is the one that we use to determine if it's safe or not to swim. You're probably aware with the Department of Health swim advisories that have to do with the levels of this bacteria. So the reason why we like to work with this bacteria, it's really easy to work in the lab, and it's safer than all of those other microbes that I mentioned before. And I'm going to walk you through a little bit how that procedure is in our lab. So what we do is you'll see our Miami Waterkeeper techs. You can see them sometimes in the beach taking those water samples. So we take a little bottle of water that's been previously sterilized, and then we collect the water, transport it to our lab. We do that on ice in a specific time. We need to get to the lab to get our results in a specific time frame. Once we get to the lab, we work with a technology that is very easy, accessible, and does not require high specialized technicians, which we love. So what we do is we add that substrate that has kind of like, think of it, the nutrients for the bacteria to grow. So we add that substrate into the bottle, we mix it quickly, and then we put it in this tray. After we place it in that tray, it goes into this little sealer, and then we put it into an incubator. So an incubator is gonna have that sample of water with that substrate for 24 hours. So this means we're gonna go home and come back to check for the results next day. So if you can see, that tray has little squares here that has the sample with the substrate where the bacteria is going to be growing. Now, that is a very special substrate, and there's going to be a signal when the one bacteria that we're looking for is growing in each one of those wells, which is enterococci. So next day, when we go to the lab and look for that bacteria, we're gonna analyze that tray with the UV light, because when that bacteria metabolizes and uses that substrate, it's gonna release that signal that we're able to see with the UV light. So what our technicians are gonna do is they're gonna get the tray and they're gonna count the number of wells that are positive for that bacteria, which is the ones that have that blue fluorescence. And with that, we're gonna go to a statistical table that's going to provide to us an estimation of the levels of the bacteria. So now we have our result. Now, when you see a swim advisory that tells you that it's not safe to swim, the DOH has a specific threshold. That means a level in which they can determine whether it's safe or if it's not safe to swim. In this case here, the DOH uses the threshold of 70 more probable number of enterococci per 100 mils. What does this mean? That means that when we get that number in that sample, it cannot exceed the 70. So if you see a beach advisory, it means that the enteric oxide that was present in that water sample was higher than 70. If it's lower than 70, then there's no beach advisory. So the 100 mils is because that's the volume of water, right? We took 100 mils of water and did this procedure. So once we do that, what we do at Miami Waterkeeper is that we not only go and measure the bacteria in the water, but we also share that with you guys, with the community, and we do that through our website. I'll show you a link in a little bit where you can actually have access if you don't have it yet and have it on your phone. So as part of our water quality monitoring, so far, we've taken already here in Key Biscayne, and you can actually see in the map, the 4 different site locations where we currently take samples here at Key Biscayne. Over a period of almost 4 years already, we have taken 847 samples, water samples. Monitoring enteric oxide and then sharing those results through a website that's called the Swim Guide. This is how the map looks in the Swim Guide, and if you have a phone and you want to take with your camera a look at the QR code, you can probably download it in your phone if you don't have it. But you can access that website, and you can see how those sites that we're currently monitoring look, because we have a weekly monitoring. So you can access this data weekly, and we also share the data of the Department of Health. So only the Department of Health is the one that makes these advisories. We share them, but we also collect our own data, and it's available in that link. So you can access that. Now, sometimes during big storms and heavy rainfall events, you're going to notice that there's a lot more of beach advisories for not swimming, right? So the reason that happens, I'm sorry, English is not my main language. The reason that happens is because when it rains, stormwater can carry all of those pollutants into our waters. So it can be all types of pollutants. It can be your pet's waste, it can be chemicals, it can be if there's spills. So all of that is just going to go and flow into our coastal areas, into our coastal waters. Also, if you have septic tanks and you haven't serviced it, it's maybe at full capacity, they can overflow. When it rains a lot, also the water table gets higher, and then you can also have an overflow, right? So there's a lot of ways into which this pollution can enter our waterways. And an example of that is something that happened here in Key Biscayne around, I believe, 2022. This was a big storm, and there was an unprecedented flooding event. This is pictures of an article that I found. So this happened a few years ago, but it's a good example of how sometimes we can see a trend in which the bacteria that we're measuring is actually being influenced or by the precipitation, by the rainfall. So to show you a little bit of what's going on in this graph over here, this axis, the x-axis over here, we have the different dates that we've been sampling. It's just a few samples in this month to portray what I'm trying to explain. On the y-axis here, we have enteric oxide. That is the bacteria that we're measuring. And you see it has a brown color. So on the y-axis, that's brown. We can see the different levels. So remember we mentioned before that 70 was the threshold of the DOH, right? So you can see it goes all the way up to 2,000 or more. And we have a little brown circles here. That means those are our observations or samples, the results for enteric oxide. But we also have rainfall variable in this graph. And we have it here in this other y-axis in blue. And you can see the inches of rainfall. So we have 0, 10 inches, 20 inches. And that's a cumulative rainfall. So a few days have passed when I'm showing you the rainfall data. So you can see here, the triangles are the blue triangles are the rainfall data. So we can see that on this day we have lower levels of enteric oxide, but we can clearly see a spike of enteric oxide all the way almost to 3,000 when we have that spike of more rainfall, right? Almost 15 inches of rainfall, then we get a very high enteric oxide signal. And then we can see how they again go down, right? We have lower levels of enterococci again with lower levels of precipitation or rainfall. So this is a good picture of how sometimes rainfall might influence the bacteria that we're measuring. Now, what does that translate? Does that mean that we have fecal pollution when rainfall happens? Well, the answer for that is, although enterococci is a valuable tool that we use for monitoring our water quality, it does not provide us a specific answer to where the source of pollution comes from. And that matters sometimes. So it's very important that we keep track of the water quality based on enterococci, but we also need to be aware that other facts or other parameters needs to be taken into account so that we can know where does it come from. So when you see high levels, does it mean it comes from humans? Is it human fecal pollution? We don't know, because it happens that enterococci can hang out in the environment longer. It can be also present in a wide variety of animals, not only humans. And do we care where it comes from? The answer is yes. Do you know why? The reason is risk changes depending on where the fecal matter comes from. So for example, many bacteria and viruses like norovirus, adenovirus are only specific for humans. So therefore, if the fecal pollution comes from humans, it's a little bit more risky, right? As opposed that it comes from other hosts. So if we want to know where that fecal pollution comes from, there's other ways, other methods, more advanced methods, which come nowadays like microbial source tracking marker that we have here. And Miami Waterkeeper has used that. That's basically we're looking for genes that are specific to a host, and we are able to measure them in the water. So to finish, this is another example of that same site where I showed you the spikes, the levels of high enterococci with high rainfall. You can see right here that we also processed, this was not that same day, it was another day, but we can see that we did enterococci, so here are the results of enterococci, very high. As you can see, much more greater than 70. But we also looked for the human markers. So this is a DNA gene that is linked to a host, in our case, human host. So you can see that we have very high levels of human marker, but we also ran a dog marker, and that dog marker was also positive. So in that one sample from that same water, we can tell that we have very high levels of enterococci, but we also have levels that indicate that it could be related to human pollution and also maybe pet pollution, right? The dogs and when we don't clean up after them, right? That can end up in the water as well. So that's a very interesting new advanced methods that Miami Waterkeeper is trying to do to have an idea of where does that pollution comes from when you guys want to know more about why are we having those high enterococci levels in our beaches or where we're swimming or where we're going, right? So yeah, in conclusion, that's pretty much what I want you guys to know. We have obviously increased risk of contamination with high precipitation and rainfall, and it is very important that we keep monitoring our water quality, right? It gives us all that information over the years that we're gathering to understand what's happening, but also to make good decisions and to really get to the point of understanding what's going on. Other methods sometimes are needed. So hopefully we can keep helping and looking into all of this as detectives in the water trying to figure out what's going on. Thank you.
Sorry, when a hurricane comes, a hurricane like right now, and the wind is blowing all the things from the ocean, the surge and all that, is that also changes the water quality, the hurricane?
Yes, it can. Because you have, for example, if you think about a hurricane, let's say that it brings a lot of flooding.
Surge, yeah.
Exactly. So, for example, let's say you live in a place where you have septic tanks. So the septic tanks are underground, right? Maybe the hurricane won't directly impact the septic tanks themselves, but when you get all that water and the water table gets up, then you get that overflow. So that flood water might be polluted with that fecal matter that's coming, overflowing, right, from the septic tanks, for example. And then the stormwater is also.
And like the drainage is not as good because the water of the ocean is way up, so it overflows.
Correct.
Into the streets and everywhere.
Yes, ma'am.
Beaches. If one was to go out in the boat further toward Elliott or toward the White Spot, would you assume that you are safe?
That's a great question, thank you. Well, we have only the 4 sites that I mentioned before, which are close to the shoreline. We would like to have more sites, and we're working on that. We need to secure more funding so that we can expand and have more sites, and ideally be able also to take into account what the community like. Maybe you guys want to sample in a specific area that is interest of you. So we would like to work in securing more funding so that we can expand. Oh, yes. So the answer for that is not quite. And you have to think of water samples as a snapshot. A water sample is a picture of a moment, an instant. The ocean is so big, the water is so much, and we take a volume of 100 mils. That's a tiny volume. So it is specific for the moment, the sampling site, that time, in that location. 2 hours later, it could be totally different. Next day, it could be totally different. Clarify, we don't work with water, drinking water, but I have quite a lot of experience working with drinking water because of my research experience. I mean, you're asking if you can use filters? Is that what you're asking? Well, it depends. I think it depends on what you're trying to achieve with the filter, and also if you give proper maintenance to the filter. But like I said, Miami Waterkeeper does not. We don't work with drinking water. But from my expertise, for example, if you have a filter and you never change it, then that filter might not be working, and it might actually accumulate bacteria.
Informative. And my first question is to Gus. Gus, what are you doing here instead of being monitoring?
That is a great question. I made a commitment.
Would you repeat it?
Oh yeah, she asked, what am I doing here when I should be monitoring or could be monitoring the hurricane? And I was, actually, my workstation just down the road at the lab is monitoring our crew, which is on the Hurricane Hunter aircraft. Actually, they just landed a little while ago. We have another mission that's going to take off at about 4:30 p.m. today. So I found a little gap in that schedule, but yeah, actively monitoring. I kept my phone on the table there so I wouldn't be tempted. But yeah, and my wife actually works in the storm surge unit over at the Hurricane Center. So she is a storm surge forecaster. So those graphics that show you how high the water might get, my wife's taking part in that. So we talk a lot about the forecast.
Underneath, and they know that
My graduate research was on exactly that. And all these thunderstorms bubble up over Africa. There's a monsoon system over there. So pretty much it means that air comes off the ocean, it carries a lot of moisture with it, it fuels thunderstorm activity over West Africa, and then there are winds that push it out over the Atlantic Ocean. And once it gets over the Atlantic, not every one will develop. That's sort of the mystery, right? Which one's going to develop and which one isn't. But we take a lot of care in watching those systems roll off of Africa and trying to predict which ones are going to turn into hurricanes and which ones are not. There's actually one right now that's probably going to become the J storm. Hasn't developed yet, but it's out there, and it's going to curve out to sea. So we're keeping an eye on it, but we're using our will to push it out to sea, so to speak. But yeah, it happens all the time. It's quite common too, and it's no threat to land. It's moving away. We like these fish storms, right? As long as they stay out there, we feel bad for the fish a little bit, but better the fish are impacted than us. So
with a storm, and you know how the rain with the rain. Is it okay, because I have 4 pets, is it okay with the rain and the water, with the sewer water, is it okay for the dogs to go out? It won't hurt the dogs, the paws, because you know, have the flooded water. Would it hurt the dogs or anything, because I have grass? Would it hurt the dogs,
I wouldn't recommend going through flood water because you don't know what's under.
They need to go back, and would it hurt? I'm asking this question, because I'm concerned.
Yeah, so floodwaters, I would not trudge through like floodwaters because you don't. I understand. I'm giving you my perspective. So yeah, I would say I don't trust what's underneath the surface of that water. Did something come in that's sharp, right? Are there other things that maybe Adriana wants to talk about in terms of water quality that could impact the animals as well? So I would be very mindful of that and recommend not going through floodwaters.
Thank you. Yes, I would recommend not to be in contact at all, if possible, with the floodwater.
So, I mean, obviously it's going to be really difficult in a situation like that. Your dogs have to go outside to go to the bathroom. Not everybody can do the pee pads, or you may not have them at home. I think probably just do the best you can in that situation. Take them outside and then rinse them off as soon as they get in. So any bacteria that might have picked up or anything that gets stuck in their fur, you get rid of right away. So just, you have to do the best you can in that situation.
So the question for anyone who couldn't hear was, when the water is contaminated, how much time, or is it a matter of time, before it begins to clear out, and what's the process, the time determining that?
Thank you for your question. So when we sample and there's a sample that exceeds the DOH threshold, we sample next day. So we do a resample. So you can see that there will always be a follow-up on that. And to answer your question about how long it takes, it depends. Because it's a changing environment. If you're thinking of the ocean, there's mixing, there's currents. The amount of the impact of the pollution can vary in size. So it varies, but we will always do a resample when there's an exceedance. That's part of the procedure, and I believe the DOH as well. Mm-hmm.
And then there's a question over here.
May I ask where you would get a daily indication of the water quality for our beaches?
Okay, so the question was where you can get a daily report of the indicator levels on the beach.
So we have a weekly report, and there will be more than one sample when we resample. I'm not aware that the beaches are sampled every day, so I don't think that. But the swim guide is a good place to look at.
Sorry, again?
The swim guide, and
the one I took the picture of.
yes, if you oh, okay, perfect. Then you can access that through their website as well, and we upload. And you can also download the data if you wanted to look at it. You have access. That's what we want, that the community have access to this data. Mm-hmm.
I was told recently that the water quality was poor on the beach, and I didn't know where to check that. And I had a friend on the island who wanted to go on the beach and into the water, and she said, "Oh no, if there's a water warning, we're not going in." So, I mean, how dangerous might it be to go into water that has had a warning?
It is dangerous because the reason that we use that bacteria that we measure is because already studies have determined a relationship between the levels of that bacteria and the risk of people getting sick of gastrointestinal illness, for example. So there has already been established the risk. What happens is that if there's fecal pollution there, you can have, for example, if you have viruses, norovirus, you can have an outbreak. There could be GI illness, so I guess diarrhea, everything that comes with. Mm-hmm.
Do you have to swallow the water to get that, or would
Yes.
it be on the surface of the skin only?
Well, it depends. There are adenovirus can affect the eyes, for example, but usually yes, it depends, and it depends the amount because it depends on. It has to do with the dose. So, for example, if you think of a children that is probably going to swallow more water than an adult. So based on age, you would expect higher risk on young people as opposed to older. If you get into the ocean and you never duck your head, right? That is less risk as opposed to if you, so because that has to do, because dose has to do with volume and concentration. So yes. Yeah.
This isn't specifically about, hurricanes and bacteria. More, Gus, this is for you. What is it like flying into a hurricane compared? I mean, so I know that those planes are obviously built for that kind of flight. You're going into these high winds and like crazy situation, whereas a commercial airline wouldn't, be able to do that, I would imagine. But what is it like inside the plane? Like, is it shaking as you're, do you go through it or do you go over the top to get to the eye? Like, how is that done?
That's a great question. So every storm is different. It does get quite bumpy on the aircraft, and we fly right through the clouds. So we're usually about 5,000 to 10,000 feet above the surface, above the ocean surface. We do have aircraft, that Gonzo aircraft that has a couple people on it, usually not our science crew, but that's about 45,000 feet above the surface. So they can be kind of above a lot of the clouds, but our P3 aircraft, Miss Piggy and Kermit, they are flying right through. And that video that I went through way too quickly showed in the beginning with the rain streaking on the windows, I mean, we're going right through the eye wall. Now, the strongest winds are usually below us, but they are usually pushing very hard on the side of the aircraft. And sometimes we'll actually have to do what we call crabbing a little bit, where we'll turn the nose into the wind a little bit, so we're almost flying. It's kind of crazy, but it's very safe, trust me. That we're kind of almost flying a little bit sideways, right, to account for the fact that the wind is blowing so hard. But every storm is a little bit different. I've been on 8-hour missions where it's shaken the entire time. I haven't lost my lunch, knock on wood. But there's also missions where really just 30 seconds, 60 seconds going through the eye wall is really bumpy, and the rest can be pretty quiet. So every storm is a little bit different, and yeah, you really don't know what to expect until you get in there. And that's one of the reasons why flying into them and collecting that data is so valuable. If we're just relying on satellite, we really don't get the whole picture.
So I have one question for you, and what are the different instruments that you use? Aerial, ocean, is it all in tangent with each other, or do you use one over the other? How do those all play into getting the data with these storms?
Great question. Yeah, there are a number of different observing systems, we call them, but really instruments that we use to observe the hurricanes in different ways. I always liken it to like the hurricane's a donut, and we're sort of sticking toothpicks through that donut to get an idea of what's happening. And we're trying to expand and improve the instruments that we're using, so it's more like taking a bite out of that donut. We get a little bit more information about what's happening. Some of the key instruments that we use all the time, one of them is called a dropson. So it's this cylinder that we drop out of the belly of the aircraft while we're flying. So it comes right out of the belly of the aircraft. We call out as the science crew when we want those to be released. And they drop in a straight line down to the surface and collect temperature, winds, humidity, and beam it back to the aircraft in real time. We also have something called the tail Doppler radar, which is a fancy word, but really what it is almost like gives us a CAT scan capability from within the storm. It has this sort of rotating beam that tells us what's happening above the aircraft, below the aircraft, and that is actually something that the Hurricane Center finds extremely valuable because they can understand what's happening all throughout the storm rather than in just like a straight line. So as we look forward, we have stuff we call emerging technologies. So we are working with drones now that we drop out of the belly of the aircraft again. We're doing that right now in Helene. This morning we dropped 2 successful drones out of the belly of the aircraft. And why these are so important is because they go to parts of the storm that we would never take people to on crewed aircraft. So this morning these drones, I was going to say the name, they're called Black Swift. It's like a cool name. But they go down and they went down into the eye wall near the surface and were able to measure the maximum winds associated with the storm. We would never fly there. From the ocean side, there's a couple of really cool instruments that we're working with. First of all, there's buoys, and there are gliders as well that are actually surface and subsurface, so collecting really critical data. But I think one of the coolest ones that we're working with now is called Sail Drone, and it's literally this little kind of sailboat with no one on it. And they direct that right into the eye wall of the storm. So in some of these storms, there's a camera on some of these, and it is incredible footage. If you want to try to search for it on social media, it's pretty incredible. And like 30-foot waves getting tossed around, some of them tumble down the side. Again, not a place you would want a person, but in terms of the technology being there, it's invaluable.
Are you able to retrieve those pieces of equipment, the drones and so on?
Not yet, actually. So we make their expendables. So we make them as biodegradable as possible. But in the future, we're working on ways that we could retrieve those. And for the drones, I still think we're a ways away from this, but it can go out and measure and then come back to us or go to land and land safely over there. But we're still a ways away from that. So these are expendables right now, but that's what we do, in order to collect the best data.
So you have a question here?
Yes, I do. I just don't, maybe this is already being done, but I wonder if younger parents are aware that when the storms are over, the children are playing on the streets with flooded waters, and you're saying how dangerous that can be for animals, for children, wouldn't it?
Can I clarify?
So the question was about whether or not younger parents know the dangers of floodwaters and their children playing in it. Okay.
Hopefully.
Thank you. Well, first to clarify, I am more aware of the dangers from a public health perspective to humans. I have not worked with animals, so I don't actually know what the risks are for pets. What I meant is, because you are the owner and you have to go with your pet as well, you or your children, yes, there are, it's recommended to avoid being in contact with flooding waters. I don't know if there's specific campaigns we have at Miami Waterkeeper, and in our website you can enter, and we have a whole section where you can have information about what are the dangers from, you know, stormwater, for example, for if you have septic tanks, but not specifically, you know, directed to children. So that's a good point. I'm not aware of this information. Maybe the Department of Health would be a good, I would suggest a good place to get that information, and make sure that, you know, parents are informed about the hazards that children could go through during flooding. But I would direct you towards the Department of Health.
So with that, I don't see any more questions, but I do see lunch has been served. So I think this might be a good place to leave it off. Obviously, you can come up to panelists afterwards if you have any other questions, but thank you so much for your participation.
Yep, there are. Yeah.
I didn't see any of them.
In the video.
That video was taken not while we were going through the eye wall. We sort of play, we first of all listen to what the crew says on board, and when we're going through a particularly dangerous part, they'll do something called set 5, which means, okay, things are getting really dangerous here, we'll all buckle in, and we are not allowed to get up. Yeah, we are. I mean, if you do, they will let you know. You need to get your butt down right now. Yeah. Because I mean, you can bump around quite a bit. Every once in a while, we'll get a bump that we're not expecting. It is not fun. It is not fun. But yeah, I wanted to take that video. We were not anywhere in the core of the storm, right?